Let's look at this question here. It says, find the equation of a circle passing through the point A, which is 4 minus 3, and touches the line x plus 2y equal to 7 at B, which is 3, 2. So look at this now. You have some point right here. You have some point, and look at this now. So this is a circle, and we have some point A, which is 4 minus 3. I'm just going to say 4 minus 3 is x is 4, negative 3. Let's say A is here, so right. Let's just still use A as here, so. And then the tangent is x plus 2y equal 7. So x plus 2y equals 7. That have a negative gradient in some sense. All right, so, and at B is a point 3, 2. If this is 4, 3, 2 is probably somewhere 3, 2, somewhere here. All right, let's say this is 3, 2. Then this would be the tangent right here. Let's just say this is a tangent. All right, and let's say this is the point B. This is the point B. Just making up some graph. I want to find the equation of this circle. Now look what we do now. This line touches the circle, so the line is a tangent to the circle. If we know that the line is a tangent to the circle, then we know that the normal is going to be a line passing through B, but not only does it pass through B, but the normal passes through the center. So if this is the center right here, it's called the center C. The normal passes through the center. Now what they're telling us is that this is the equation of the line. So if you make y the subject, from this you get 2y is equal to, that look like minus x plus 7. And so if you divide through by 2, then what we're seeing is that y is equal to minus a half x plus 7 over 2. So what that means to tell us is that the gradient of the tangent, right? The gradient of the tangent, this is the tangent. The gradient of the tangent is minus a half. So the gradient of this line is minus a half. If the gradient of the tangent is minus a half, then that is telling us that the gradient of the normal, this right here, the gradient of the normal, which is perpendicular to the tangent, so the gradient of the normal is 2. So the gradient of the normal is 2. Yeah, man, the gradient of the normal is 2. Now what I like to do is I like to call my center AB. So I'm going to call my center AB. So I'm going to call my center AB. Now guess what I know? I know that the gradient from B to C, so the gradient of B to C, that's just the gradient of the normal, and the gradient of the normal is y2 minus y1, so it's B minus the y value at point B, so it's B minus 2 over, so B minus 2 over, what else now? What else do I know? B minus 2 over, where it is, B minus 2 over A, x2 minus x1, A minus 3, and what that is equal to 2. So if I cross multiply this right here, I'm going to end up with an equation that says that B minus 2 is equal to 2 times A minus 3. And so what that gives me then is B is equal to 2A minus 6 plus 2. And so what that tells me then is B is equal to 2A minus 4. That's the equation for B. B is equal to 2A minus 4. If this is an equation that I get that b is 2a minus 4, now look at this now. I know the point b and I know the point a. Now I know that if I were to have b and a, if I were to find the gradient of BA, I know that the bisector of BA passes through the center of the circle. This is the bisector of BA. Let's call the bisector B. The bisector of BA. So we need the gradient of the bisector. So first thing we need to do is find the gradient of BA. So finding the gradient of BA, what we're going to get is the gradient of BA is equal to y2 minus y1. So the y value at b, y2 minus y1. So it's 2 minus minus 3, which is 2 plus 3 over x2. So let us see, 2 minus minus 3 over 3 minus 4. That's the gradient of BA. So 2 plus 3 is 5. And so 5 over 3 minus 4. 3 minus 4 is negative 1. So the gradient of BA is negative 5. Beautiful. Gradient of BA is negative 5. Now that we get the gradient of BA is negative 5, then that means that the gradient of the bisector is equal to 1 over 5. That's going to be the gradient of the bisector. So the gradient of this line is 1 over 5. Now that we know that the gradient of the bisector is 1 over 5, we also know that the bisector passes through the midpoint. So now the bisector passes through the midpoint. So we need to find the midpoint of AB. So let's write the midpoint of AB. The midpoint of AB is going to be equal to, the midpoint of AB is 4 plus 3 is 7. So the midpoint of AB is 7 over 2, comma, midpoint of AB is 7 over 2, comma, then minus 3 plus 2, minus 3 plus 2, divide by 2, that's minus 1 over 2. That's the midpoint of AB. Now that this is the midpoint of AB, what are we going to get? Well, the equation of the bisector is now going to be y minus minus a half. So it is now y plus a half. Y plus a half is equal to, y plus a half is equal to gradient of the bisector, which is 1 over 5 into x minus 7 over 2. Now all we need to do now is simplify this, and what we're going to get is, make y the subject, we're going to get y is equal to 1 over 5x, and then simplify this. I really don't like so much fractions yet. 1 over 5 times minus 7 over 5, minus 7 over 2, then we subtract a half, so I get minus 6 over 5. So this works out to be minus 6 over 5. Now look at this. Now we can insert the center. The center will satisfy the equation of this line. And so since the center satisfies the equation of this line, what we're going to get is replace y with b to say b is equal to 1 over 5. B is equal to 1 over 5 times x. B is equal to 1 over 5 x. B is equal to, why does this one come out this way? All right, b is equal to 1 over 5x, but replace x with a, so b is equal to 1 over 5, a minus 6 over 5. So all we have to do is multiply through by 5, multiply through by 5, then this equation is going to become 5b is equal to a minus 6. Now look at that, we have 5b is a minus 6, and we also have b is equal to 2a minus 4. So if we solve these two simultaneously, let's plug them together. So we're going to get 5 times, plug b in here now to get 2a minus 4. That's equal to a minus 6. Now expanding this bracket, we get 10a minus 20 is equal to a minus 6. Now look at that. What that implies then is that bring over this a over here to get 9a, bring over this 20 over here to get, let's see, did I expand this right? 5 times 2 is 10, 5 times 4, 20, bring over the 20, minus 6 plus 20 is 14, so I get 9a equal 14, and so that is giving me just want to make sure I did all this fraction correctly. Usually this works out to be some whole number. So did b is b really 2a minus 4? We're just going to take a glimpse up here. Just going to take a short glimpse up here again. Did we expand everything good? That's 2a minus 6. Bring over this. Minus 6 plus 2 is minus 4. Expanded right. Let's check down here again. Minus 7 over 10. Minus a half. Minus 6 over 5. Yeah, this is correct. Multiply 2 by 5. That's 5b is equal to times 2 by 5, a minus 6. Replace b with 2a minus 4. 5 times 2 is 10a. And then 5 times minus 4 is minus 20. Add 20. This becomes 14. Subtract a. That becomes 9a. So what we get is that a works out to be 14 over 9. A equal 14 over 9. Now that we get a is 14 over 9, then we know what b is. We know what b is now. Since we get a is 14 over 9, we know what b is, because b is, what was b? b is 2a minus 4. And so b works out to be, let's write it down. So b works out to be, plug a right here as 14 over 9. 2 times 14 over 9 minus 4. So b works out to be minus 8 over 9. Now that we get a and we get b, we'll find the center of the circle. So now we get the center of the circle. The center of the circle is 14 over 9, 8 over 9. So how is that helpful? This is very helpful. This is very helpful because look at this now. Because the center is now 8 over 9, right? So we know the center is 8 over 9, 14 over 9, 8 over 9. And we know b is 3, 2. Center is, let's check again. It keeps running. So the center is, what we got for the center? b is minus 8 over 9. So 14 over 9 minus 8 over 9. All right, so let's find the radius now. So the radius is going to be the distance from b to the center. So the radius is equal to the square root of, it's going to be x2 minus x1. So it's 3 minus 14 over 9. 3 minus 14 over 9 square to give us the radius. 3 minus 14 over 9 square plus the y value now at b, which is 2 minus, the y value at b was minus 8 over 9, so it becomes 2 plus 8 over 9 square, all square rooted. So we work this out to get the radius. Put all of that in the calculator. 3 minus 14 over 9 square plus 2 plus 8 over 9. 2 plus 8 over 9 square, square rooted. So I get 3.23. That's the radius I get, 3.23. That's the radius, which is 10 and 35 over 81. All right, so let's use 3.23. So what does that mean? That means that the equation of the circle then, since the radius is 3.23, let's write down the circle. So the circle C, the equation of the circle is given by x minus a, so it's x minus 14 over 9, x minus 14 over 9 square plus y minus the y value at the center, which is now y plus 8 over 9, y plus 8 over 9, all squared, and that is equal to r squared. That's equal to r squared. And what is r? 3.23. So it's 3.2 square. That's the equation of this circle. That's the equation of the circle. Nice and easy, soft. Okay, now of course, we're going to go through verification to check and show you that this is indeed true. I'm going to draw a circle and I'm going to set up all of these scenarios. So we want the circle to pass through this and this and have a center of 14 over 9 and minus 8 over 9. So let's go ahead and do that now. So let's set up our sketch now. All right, so here's our sketch. We want to make sure we go to our graph, rectangular grid. Let's change the axis a little bit because we're going to need 14 over 9. 14 over 9 is some fraction. Just trying to have some fractions in it. All right, just to open it just a little bit so I can see the fraction a little bit better. 14 over 9 for the x value. 14 over 9 is 1.555. 14 over 9, somewhere 1.5, 1.6. Somewhere right here is 14 over 9, and then the y value is minus 8. So we just need to want to move it up. Minus 8 over 9. Okay, this is fine. Let's go. 14 over 9 is here, then minus 8 over 9. Minus 8 over 9 is less than 1. Minus 8 over 9 is somewhere minus 8 over 9. Somewhere about here. Let's put it right there. All right, this is not 100% accurate. Now this is a circle and we want a circle that passes through A. A is the point 4 minus 3. This is 4. I want to pass it through 4 minus 3. This is 4 minus 3. And it should also pass through 3, 2. Where is it? 3. Is it 3, 2 or 2, 3? 3, 2 or 2, 3. It should pass through 2, 3. Actually 3, 2. It should pass through 3, 2. So let's check if it passed through 3, 2. Slightly above 3, 2. So as I can say, this is not 100% accurate because of the center. You need to get this center spot on to 1.55. You need to be in this middle. All right, so I'm having some difficulties with the scaling right here. Let me try one more time. All right, so the center is minus 14 over 9. 14 over 9 is 1.55, so this is somewhere about here. And y value of minus 8 over 9, somewhere about here. And then we know that it passed through 4 minus 3, 4 minus 3 somewhere here. And it should pass through 3, 2. So this is roughly what we have, all right? Roughly what we have. So that's roughly what we have. This is roughly how the circle looks. Now, I'm going to insert now, but new function, y equal to, the graph was x plus 2y equals 7, so y was equal to, I made y the subject, y was negative x over 2 plus 7 over 2. All right, that's that line there. That should have been a tangent to the circle. So I need to move the circle just a little bit to make it be a real tangent. Something like this. All right, and then we know that A is the point on the circle right here. All right, this would have been the circle. So according to my graph, according to this graph, this is 3, this is 2, this is 3, 2, this is our point B, this is our point A, and this is a tangent at B. According to our graph, the center should be, this is 1 minus 1. The center should be 1 minus 1. That's what it is saying. And the radius is 1, 2, 3, 3 point something. The center should be 1 minus 1, but we didn't get 1.1 minus 1. So let's go back and see what happened. Gradient of the normal is 2. B minus 2 over A minus 3 is 2. Cross multiplied, B minus 2 is 2A minus 6. Bring over the 2. B is 2A minus 4, yeah. Gradient of AB is now y2 minus y1, 2 minus minus 3 is 5 over 3 minus 4, negative 1, negative 5. Gradient of the bisector 1, 5. Midpoint of AB is 7 over 2. Then minus 3 plus 2, minus 3 plus 2, minus 3 plus 2 is minus 1, divided by 2 is minus a half, so that's good. So then solving this, that is, bring over the half, you get a 1 over 5x minus 7 over 10, minus 7 over 10 minus a half, minus 7 over 10 minus a half, it's minus 6 over 5, good, multiply through by 5, so that's 5b equal a minus 6, 5b equal a minus 6, so that is 5 times 2 is 10, 5 times 4 is minus 20, a minus 6. All right, bring over the 20 here, bring over the a here, subtract a, 9a, add 20, add 20, 14. Yep, so this is what we get. This is what we get. Now, just to check it one last time, I'm going to go with Symbolab and look at this. Let Symbolab do it for me. So this is Symbolab. Go to Symbolab. I'm going to let Symbolab look at this circle that I have. X minus 14 over 9. X minus 14 over 9. X minus 14 over 9 plus y plus, this was 8 over 9. And that was equal to, what was this again? We had radius was found to be, what was that? Ten and 35 over 81. 10 and 35 over 81. So that's this, and I want to plot the line y equal to minus x over 2 plus 7 over 2. Yep, so the equation that we do is right. So the tangent there and the point 4 minus 3 is on this circle. So yeah man, we think govern. So this is right. This is the correct graph showing it. It showed that so circle here. So the tangent there touch it at 1 point. So we're good. Nice. Let's look at this last question right here.